In this video, we will study about Austempering and Bainite. So we have seen some of the heat treatment processes like annealing, normalizing, and quenching. So we will study about the heat treatment process that is Bainite. So let me draw the TTT diagram here. Okay, so the TTT diagram like this. You have the C curve here. You have the finishing C curve here. This is start and this is finish. Okay. And above it you have the uh, stable gamma, and here you have unstable gamma, stable gamma, and here you have gamma plus pearlite, and here you have pearlite. See, earlier we have seen some examples like this annealing and normalizing. So in Austempering, what we are doing is that we are just cooling at a faster rate like quenching. And then for at this particular temperature, that is before this martensite forms, the martensite is forming, so here the martensite formation starts and here it is finishes. So here you have martensite, here you have gamma plus martensite. Okay, okay. So we are stopping here, then holding this material at this temperature for a period of time. So it finally gets converted to bainite. Okay. So this is not, it is a different microstructure than that of the beer light. Okay. So this is called Aus tempering. That means we are missing this, we are calling it below the nose, such that it does not touches the nose of the seeker, that is just like quenching. Then at this particular temperature or around this temperature, we hold it and get this bayonet. So again, this bayonet is a fine lamellar structure of this alpha and Fe3. See, just like the uh, pearlite, but here the difference is that it has a fine needle of Fe3 in alpha metal. Okay. So you know that at a very low temperature, the nucleation rate is very high and the growth rate is very slow. Okay, so that is why we are getting a structure like the fine needle shaped cementite in the alpha matrix. So you need to know that the pearlite and bainite are mixture of the same two phases, that is alpha and Fe3C, but are different, but are different micro constituents. Micro constituents due to different shapes, due to different shapes and distribution of these spaces, distribution of these spaces. So that is the difference.